Hi, I'm Sara Dorothy, and in this video I will be discussing Experiment 4, the preparation and reaction of the Grignard reagent, phenyl magnesium bromide, and benzophenone, and the isolation and purification of triphenylmethanol. The experiment was divided into two parts. Part 1 consisted of producing the Grignard reagent, phenyl magnesium bromide, and then carrying out a Grignard reaction through the addition of benzophenone. This part of the experiment had to be kept anhydrous to avoid an acid-base reaction of the phenyl magnesium bromide. If water came into contact with the Grignard reagent, it would produce an unwanted byproduct known as benzene. The reaction was kept dry through the use of new septums, a calcium chloride tube, and a few syringes. The phenyl magnesium bromide is often referred to as a mass carbanion because it can be easily broken down into the benzene ring carbanion and can be used as a base. Part 1 began with the addition of iodine crystals to 18 milligrams of magnesium, which was then placed on a hot plate and spun. The iodine was used to clean the surface of the magnesium to allow it to react with the bromobenzene. This was complete when an orangish color was deposited on the walls of the reaction vial. In some cases, it also appears purple, also known as a purple haze. About 1.5 milliliters of ether was then added to the reaction vial that contained the iodine and magnesium. After about 15 minutes, when the iodine was dissolved, the reaction went from the color brown to orange and then turned into an off-white solution. Following that, a solution of bromobenzene and ether was added to form the Grignard reagent, phenyl magnesium bromide. The heat was turned off, and when the solution cooled to room temperature, the benzophenone was added and reacted with the Grignard reagent and created the magnesium alkoxide of triphenylmethanol. The reaction appeared dark pink and there was magnesium in excess. HCl was then added to the solution and it reacted with the excess magnesium and protonated the oxygen on the magnesium alkoxide, turning the solution clear and into two separate layers. The HCl was added until the solution tested acidic on pH paper. The second part of this experiment consisted of the isolation and purification of the triphenylmethanol that was synthesized in part 1. We also performed a thin layer chromatography to test the purity of the crude product and presence of any byproducts. The product from part 1 consisted of a top organic ether layer and a bottom aqueous acidic layer. The top layer contained our desired product, and ether. The product was treated with several scoops of anhydrous sodium sulfate and passed through a filter column of sodium sulfate to remove any of excess water. And then the ether was boiled off in a hot sand bath. After the ether was boiled off, hot methanol was added, and the solid triphenylmethanol dissolved and recrystallized shortly after being placed in an ice bath. After the solids were filtered out through a Hirsch funnel and collected, I collected 26 milligrams of pure triphenylmethanol from 109 milligrams of crude product, yielding a 24% yield. The melting point of my pure product ranged from 157.6 degrees Celsius to 158.4 degrees Celsius. And then the limiting reagent in this reaction, according to my theoretical yield calculations, was the benzophenone, and my calculations go as following. Thank you for listening, and I hope you have a good day. See you in class.